Hey, this is Mr. A, and this is Pre-Calculus Honors. We're going to be doing section 2.2 today, and that is polynomial functions of a higher degree. We've been taking a look at quadratic functions, which is polynomial functions to the second degree, x squared, but we're going to be taking a look at even higher degrees, x to the third power, x to the fourth power, x to the fifth power, and so on and so forth. And so what we're going to start off with is what's called the leading coefficient test, which means all we really care about is this leading coefficient. We could care less about what comes after it. This leading coefficient is going to tell us so much about our polynomial function. And the main thing we're going to look at in this is this a sub n, is this coefficient on here, is this going to be a positive or negative value? And also, what is the degree up here? Is this an even number or is it an odd number? What is the degree of this leading coefficient? So let me show you something, and this is something that we're going to be really working on getting very comfortable at in this terminology. And so here we have the n number is going to be odd. And so you can see right here we have x to the third power, and it is a positive value. This a sub n is equal to a positive value right here. So when we're positive and this is an odd number right here, my function is always going to be coming down here and up here. And we have some different ways to designate that, and this is the terminology that I want you to really get. Let's take a look at this one on the right hand side. I'm going to say as the limit as x approaches infinity of my function. Okay, so what this means is as our x value, as we keep going to the right, as the x value goes towards infinity, as we go towards this limit, can you see my function is going up towards positive infinity? We call that the right-hand behavior, Now take a look at the left-hand behavior. How do we talk about this? The limit as x approaches negative infinity. What does this mean is as x goes this way towards negative infinity, as x is getting less and less and less and less, what's happening to my function is it's going down, which means my y value is going closer to negative infinity. And this is true for all odd functions where the a is positive. But look at here, we still have an odd value. We have an odd number. Our n is equal to 5. But you can see this a is equal to a negative value. So do you see what happened here is my n behaviors swap-swapped, didn't it? Which means the limit as x approaches negative infinity, as we're going to the left-hand side towards negative infinity, this function is getting bigger and bigger and bigger. It's going towards positive infinity. It's going up. And as you can take a look on this one, the limit as x approaches positive infinity, as we keep going to the right, my function is going down, isn't it? Which means this f of x, this y value, is going towards negative infinity. For odd values, the right-hand and the left-hand behaviors are always opposite of each other. Okay, so if you know this positive odd value, this green graph right here, you can conversely know the red graph as well. Okay, but let's take a look at what happens if my n value is even. So you can see we have an x squared graph. This is a quadratic, an even number right here, and you can see how this is the a is a positive value right here. So the limit, we're going to start with our left-hand behavior, the limit as x approaches negative infinity, as we keep going this way towards negative infinity right here. I'm going to clean this up a little bit. Negative infinity. My function is going up, isn't it? It's going up, which means it's going positive infinity. Look at the right-hand behavior. The limit as x approaches positive infinity, as we keep going to the right, where's my y value going? My f of x is going towards positive infinity. And so that is a positive, even polynomial. Let's take a look at a negative. So the a is going to be a negative number. It's still an even polynomial. Let's take a look at the n behavior. Take a look at this n behavior. Take a look at that n behavior. Let's start with the left-hand n behavior. How do we say this? The limit as x approaches negative infinity, f of x is approaching negative infinity. It's getting lower and lower and lower and lower, which means the limit as x approaches positive infinity, as we keep going to the right, the f of x is equal to, no it doesn't. It's going towards negative infinity because it's going down, isn't it? Now, even functions will always, their end behaviors will always be the same. They'll always be either positive infinity and positive infinity, or negative infinity and negative infinity. So let's take a look at some examples here. We're going to apply our leading coefficient test to describe the end behavior. So take a look here. My a value is going to be negative. I have an odd function, which means, if you remember, our even function looked like that, our odd function looked like that, didn't it? Which means, what can we say? The limit as x approaches negative infinity of my function is going to be going up towards positive infinity. The limit as x approaches positive infinity of my function, the end behavior on the right-hand side, is going down towards negative infinity. Let's take a look at the second function. This second function, this is a positive value. It's a positive value, and it is an even function. So if you remember, positive even functions, they look like that. And so you can see, look at this end behavior right there. This end behavior, the limit as x approaches negative infinity, my function is going to be approaching positive infinity. It's going up at the end behavior. The limit as x approaches positive infinity, the f of x is approaching positive infinity, because they're both going to be finishing off at the same place. And so that is applying our leading coefficient test in order to find our end behavior. Now, we can also find our zeros of a polynomial function. So take a look at this. We have a polynomial function, f of x equals x cubed minus x squared minus 2x. So what are we going to do? We're going to try to factor. Let's pull out an x. So we're going to pull out an x, which means we're left with x squared minus x minus 2. Now, what can we do with this guy right here? We can try to factor this. What are the factors of negative 2? Are negative 2 and positive 1. Okay, so we have x minus 2, x plus 1, negative 2 and positive 1 add up to the negative 1 in the middle. And so let's take a look at my zeros. What's my 0 right here is x is equal to 0 is one of my zeros. What's my 0 right here? X is equal to 2, because 2 minus 2 equals 0. Or this one right here, x is equal to negative 1. And so what do I know? I know x is equal to 0 is 0. I know positive 2 and negative 1. Take a look at my function. Let's try to sketch my function. It is an odd function, isn't it? And it's a positive odd function, which means if it is a positive odd function, I know as I'm coming this side, as the limit approaches negative infinity, remember, as the limit approaches negative infinity, my function is going to be approaching negative infinity. What do I know about the odd function, positive? The limit as x approaches positive infinity, we're going to be approaching positive infinity. And so we're going to be going that way, which means, can I just simply sketch out the in-between part? Sure. This is going to come through and come down and then come back up. And so I'm not really worried about where these relative minimums and maximums are. What I'm really worried about right now is, where are my zeros? We have our zeros. And what's happening with my end behavior? Where am I going with my end behavior? And I can use my leading coefficient test to figure that out. Let's find some more real zeros, okay, of my polynomial function. And so what am I going to try to do here? Let's try to factor something out. Let's factor out a negative 2x squared. And so when I factor in negative 2x squared, I get x squared minus 1. X squared minus 1. And so that is where I'm at thus far. Now, if you can take a look, I can also factor out this x squared minus 1. This is a perfect square, or actually not a perfect square, but one of my x plus 1, x minus 1, because the middle number cancels out. And so now I can know my zeros. What are my zeros? Well, look at the degree on this. This is negative 2x squared. So x is equal to 0 is obviously 0. But because it's x squared, I have more than one 0. I have another 0, x is equal to negative 1. And you might say, Aiden, why do I have to write both? You do have to write both, because it's x squared, which means it's really, if I kind of factored this out, it would be negative 2 times x right here, which means they're both zeros. And that's called, it has a multiplicity. of 2, which means there's 2 zeros right here. I know I have x is equal to negative 1. I also have x is equal to positive 1. So let's try to graph this out. We have positive 1, we have negative 1, and we have 0, and we have 0. I know, I just did the exact same thing twice. Take a look. It's a negative function. It's an even function. So I know it's going to be, its end behavior is going to be down there. It's going to be down there as well. And so what's going to happen is it's going to go through this point. It's just going to touch down and then through that point right there. Okay. And so something I'll in the next slide I'll show you is when things have a multiplicity, it just touches that axis. It doesn't go through that axis right there, and so it is still a 0. Let me give you an example of what I'm talking about. Here you can see how here I have x is equal to positive 1. I have x is equal to positive 1, which means there's a multiplicity there. There's the same exact 0. I have x is equal to negative 2. I have x is equal to negative 3. So take a look. I have negative 3. I have negative 2. Do you see how the graph is going through these points? Okay. But for the thing with the multiplicity of x is equal to 1, it just touches down on that. It doesn't actually go through that point. It just bam, bam. Good. It just touches down on that. And since this is an x to the 4th graph and it's a positive graph, I know my end behavior is going to be going towards positive infinity on both sides. Okay, and that'll help you to construct graphs. Okay. One last thing is, how do we find a polynomial function given our zeros? Now, of course, if I have this one right here, x minus 1, x minus 1, x plus 2, x plus 2, you're just foiling. One step at a time, you're just foiling, and it is just a lot of elbow grease. It is just hard work. Okay, I'm going to show you a little bit more complicated one where there's a radical involved. We have 2 plus square root of 11, 2 minus square root of 11. And so what do we know is our function is going to be x minus 3, because that's a positive 3 is my 0. We have x minus, and in parentheses, we have 2 plus square root 11. And then we have x minus, in parentheses, 2 minus square root 11. And so I'm going to do a little bit of foiling. Okay. Now, an easier way to go about doing this foiling is this. I'm going to show you. This is why I'm doing this. A little bit tougher of an example. In this middle function, I am going to call this x minus 2. I'm just kind of moving the parentheses a little bit. Plus square root 11. And here we have x minus 2 minus square root 11. Okay, actually this is minus minus, that's a plus. This is minus plus, that's going to be a negative right there. And so I'm going to fix that a little bit. Square root 11 there. Okay, now you might say, Aiden, how did this kind of help me out? This is one of those functions where when we do the foiling, look at the middle value. It's the exact same thing, but he's a minus and he's a plus, which means the middle value is going to cancel out. And so we have x plus 2 times x minus 2 times x minus 2, which is x minus 2 squared. The middle numbers cancel out. Then we have negative root 11 times positive root 11. That's minus negative root 11 squared. And we can clean this up a little bit, which is really, really, really nice. So we have x minus 3. We have x squared minus 4x plus 4. That's what when we FOIL the x minus 2 squared out. Minus square root 11 squared, which is minus 11. Now what do we want to do with this 4 and 11? This 4 and 11, this 4 minus 11, we're just going to call that negative 7. So are you guys cool if I won't do that, I'll just do another step. So we have x minus 3, we have x squared minus 4x minus 7. And now I can do my last bit of foiling. Okay, I'm going to take my x, I'm going to multiply it through, so we have x cubed minus 4x squared minus 7x. Okay, then I'm going to take my negative 3. Negative 3 times x squared, that's negative 3x squared. Negative 3 times 4, negative 4x, that's plus 12x. Negative 3 times negative 7, plus 21. You can see the reason I did this, it makes it a lot easier to add up. We have x to the third minus 7x squared plus 5x plus 21, and that is my function for this. Oops, my bad. This is my function for these zeros of the polynomial. Again, all of this from about here down. I'm going to draw a little bit of line. From here down, it's all elbow grease. It's all just hard work. Setting it up is the hardest part of the problem. And so if you set up the rest of the problem, it's just a lot of work. That's it. Finding the zeros. Okay, that is Polynomial Functions 2.2. See you guys.